All right, moving on. Let me introduce you to the next speaker for the day. I'll not take much time because we are already a little late. All right, in the meantime, please leave your feedback for Eamon in slido.com. Please choose track 2 as the room. Once you go there, the poll is live already. You can see 5 questions, 5 or 6 questions in the poll tab. Please go there and leave your feedback for Eamon. We would like to see how you felt about his session. So please do that because we need more and more feedback coming in. And I really hope all of you are doing the tweets. We just saw the screenshot by our team. We already have more than 350 tweets, actually. That's a great number. And I don't remember the names. There were a couple of names of the people who have been tweeting the most. I think one is Raj.
It's on? Okay, there it is. Do you believe how you develop and deliver software is critical to the success of your companies? Do you believe there's opportunities to change how you do development and delivery of your software that would improve the effectiveness? But do you struggle to get people to commit to making investments, to make changes in your processes so you can become more effective? And then once you make a change, do you struggle to get people to understand that you had an improvement and show them the actual improvement that they made for the investment? If you answered yes to those 3 questions, you're like most clients I work with out in the industry and the organization on an ongoing basis. And if people know me well, ever since I led this large-scale transformation at HP, I've been trying to help as many people around the world realize the benefits that I had in this transformation because it had such an impact on us. We went from firmware for the organization with 800 developers being the bottleneck for the entire organization to driving a 2 to 3x improvement in productivity. Based on that experience and trying to help as many people as possible, I spend as much time as possible out in the organization trying to help people. I'm somewhat unique in that you're looking at my entire company, and when I engage with customers, I don't just come in and give a presentation and leave. If I'm going to engage in an organization, I do workshops, I do executive workshops because I'm an executive that has led a large-scale transformation. I speak their language, I can help them on the journey. I also do execution workshops where I help people figure out what are the things that they should improve and help coach them on their continuous improvement journey. And I think that gives me somewhat of a unique perspective because unlike other leaders in the industry that are researchers or engineers, I'm somebody that continues to learn about what's working and what's not working along the journey. I do a lot of webinars, I do a lot of speaking engagements like this, I do podcasts, I do other things to try to help you avoid mistakes that I've already made. I've been working in this space for a long time. It's not that I'm smarter than anybody else, I've just been making mistakes longer, so I can help you avoid the mistakes I've already made. It's okay to go make new ones, but if there's an opportunity to help you learn from what other people have done, that's one of my goals and types of things that I'm out there for. And about last fall, I was watching a lot of my clients struggle and really struggle to deliver the capabilities that they needed to as fast as I could and deliver the business results. And it started to piss me off. And I started to come to the conclusion that we needed a better way. We needed a better approach to drive improvement in software. And I grew up in manufacturing where there was a very structured approach to driving improvement in the organization and delivering those capabilities and delivering those business results. And I started thinking that that's really what we need for software. I went to DevOps Enterprise Summit last fall and started discussing these ideas with some other people. And people go, yeah, we need to do exactly what manufacturing did. And as a process engineer in manufacturing, I'm like, no, we can't do that. I grew up at doing that, but software is a very different beast. We can learn a lot from what they've done from 70 years and fine-tuned and improved to deliver real breakthroughs in the business, but we've got to adjust it and fine-tune it to fit software because software is very different. But we can learn from them, and there's a lot of leaders that I look to, starting with Deming. I don't know, people with a software background have a good feel for some of these leaders and what they've done, but Deming went to Japan after World War II because nobody was really listening to him in the United States and helped them transform from a country that was known for low quality cheap products. And he fundamentally transformed that, and he's a lot of the leaders of starting with the continuous improvement stuff. Goldratt really came in and focused on this from a throughput perspective and trying to figure out where they're constraining the process and how to optimize flow through manufacturing organizations, and then taking that broader beyond manufacturing organizations. And typical organizations that implement his theory of constraints see a 70% improvement in productivity. Can you think of things that you would do with a 70% improvement in productivity? And then the other is Taiichi Ohno at Toyota. He drove the kata process, and the kata process is really a very systematic approach for driving continuous improvement into an organization. And the job of leadership is to engage everybody in the organization in that systematic approach, teach them the process, help them and learn, and then encourage everybody in the organization to drive that continuous improvement and make it happen. And these are great thought leaders. They've taken Toyota to where they're a dominant player in the marketplace. Goldratt, 70% improvements, and Deming fundamentally transformed Japan and made them a powerhouse in the industry. But we can't just copy what they did in manufacture. In manufacturing, it's very hard to build early prototypes. You got to manually put these things together. It's hard. So they started managing things with what they call a stage gate R&D process, which is we have specific phases when we put things together. We plan things in a lot of detail. We put them together. That's the basis for the product development lifecycle in software. But software is different. We can start building from the very first line of code. We can start deploying the very first line of code. We can start testing. That is our manufacturing process. It's our deployment pipeline. We can do that from the very beginning. And software is different in that you usually, in product development, you have one team that designs a product, and then you have a manufacturing organization that's focused on continuous improvement of quality and flow through the manufacturing process. And in software, we have to think about both of those things at the same time. And we've got to compete with the product ideas, with the continuous improvement ideas, and sharpening the saw. And that's a unique challenge for software. The other thing that's unique about software is in manufacturing, we're producing the same thing over and over and over again with as limited variability as we possibly can. In software, every time you run the manufacturing process, the product is changed. So in software, what we need to be doing is we need to be enabling the process and the product to change at the same rate. And lastly, in manufacturing, you can go walk around the factory floor. You can see where inventory is building up. You can see quality issues where things don't go together. And when we get into software, we typically go in to look at our process, and it looks something like this. And can we expect anybody in the organization to engage and figure out how to help us invest in continually improving and investing in changing things if we don't make visible the problems? In manufacturing, they start with a very simple view. This is the product design. It has the bill of materials. These are all the pieces and parts that have to be assembled together to deliver it. And then they start to design the supply chain. And designing the supply chain, you're looking at what are all the different pieces, what are all the sub-assemblies, how do you draw the components, how do you put them together, where do you manufacture them, how do you distribute them, where do you hold inventory. And they spend a lot of time designing the product and the manufacturing process at the same time so they can optimize the efficiency and effectiveness of the whole system. For software, if we've got a nice loosely coupled architecture, our deployment pipeline can be as simple as this. We have a few developers that will work on code, they'll check it in, they'll put it into a test environment, they'll make sure it's working, they'll do a canary release, they'll check to make sure that it's working as a canary release. And a lot of what you hear talked about as DevOps is this very simple model. Everybody wears a pager, it works for everybody. And we need to get this continuous integration, and we need to get developers delivering code into production. And as I look at this, and I work at very large organizations that have tightly coupled architectures that are complex, a lot of those ideas don't make sense. They're not as an effective way to do it. You know, if you have hundreds of people working on an application, the chances are the person who's wearing a pager that day knows anything about the change is very low. You're going to have more specialized duty. And I've been harping on this for years. You take one approach if you can independently develop, deliver, and qualify code. you take another set of process for large, tightly coupled systems. I've been arguing with Gene and Jez for this for years, and they finally, in the 2017 DORA report, went back and tested for architectural independence. That exact same question is, can you independently develop, qualify, and deploy your code? And what they came back and found out is everybody that's doing DevOps correctly, according to the DORA report, has a loosely coupled system. My conclusion was, great. Now we can finally start talking about how you do DevOps for large, tightly coupled systems. And their answers as researchers looking in this space is, no, the answer is clear. What we need to do is go tell everybody that they need to re-architect their systems and go to loosely coupled. As somebody who led 800 engineers around the world through a process of completely rewriting 10 million lines of code over 3 years, that is not something I'd recommend lightly to somebody I didn't like, and certainly wouldn't recommend that lightly to a friend. It's hard, it's complex, it's not necessarily the first step. But the principles that you use for how you think about DevOps apply to tightly coupled systems as they do to loosely coupled systems, but the approaches are different. And this, what you're trying to do is you're trying to give feedback as quick as possible to these people, and you're trying to do that in a test environment. If you do this, you can do this with continuous integration, you can do canary releases into production, but if you've got a large, tightly coupled system like this, you can't build it frequently enough, deploy it frequently enough to get to a smallest number of committers into a build that it's easy to triage effectively. And for this, you need to take a different approach. You can go to a smaller subset of testing. You can go to automation to build and deploy more frequently. But at some point, that's not going to be enough to get it to a small, localized enough system. And you take this system and you use service virtualization to enable you to test and qualify those components independently. And then over time, you break those into subsystems that can be built up. And with this type of approach, you really end up with a deployment pipeline that looks much more like this. You have a bunch of independent components that need to come together. They get built into subsystems. And with manufacturing supply chains, what we're trying to do is we're trying to minimize inventory and where we hold it by looking at demand variability. What we're trying to do with our deployment pipelines in software is we're trying to localize the issues back here before they impact a broader number of people. And we need to work through that. And our very first step to driving continuous improvement is trying to understand what kind of problem we're trying to solve. We need to start with a very simple view of our deployment pipeline. And the way I start with this with most organizations is describe all the environments that you go through, and then you have this very simple manufacturing process that you use. And in manufacturing, they focus on improving this and continually improving it over time. What we tend to do in software is, because it's so easy to develop our manufacturing process and our manufacturing lines, is when we have problems with it or we can't get through the process quick enough, what we tend to do is we branch our code, which is basically we're replicating our manufacturing process multiple different times. You would never do this in a manufacturing organization because it's very costly, expensive, and it's very visible. The nice thing about software is it's not very visible. We can hide this from all the managers, and they don't know that we have all this duplicate work, and we don't know that we're wasting all this time and energy. It's expensive. It's very wasteful in software, too. It's just not as wasteful as it is for other organizations. So part of mapping out and making our factory visible is making all the branches and all the duplicate factories in our organization very visible. This is for a large, tightly coupled system where you own the deployment process. And it's nice that you can own the deployment process because you can still do things like canary releases. You own how frequently you deploy. But if you're a large company developing customized off-the-shelf software, you've got an additional problem. And that is your customers are not updating as frequently as you would like them to. So you're not releasing very frequently. You're maybe doing every 9 months, or you're doing every 6 months, or you're doing once a year because you can't get your customers to update. The challenge that that has for you is a lot of them don't want to update because it's very hard and expensive. So you have the additional challenge of you're having to support branches that are years and years old because I don't want to go through the pain of updating, so I really want you to make sure that you're delivering me a patch on this thing. And that comes because you're not making it easy for them to deploy on an ongoing basis. You're not getting them to own it, and you're not really giving them good tools to build in quality for themselves. And a lot of times you don't know how they're customizing the product, so you're not catching quality issues. And the reason they don't want to go to the latest versions in this system is because when they go to the latest version, everything breaks, and they've got to go through a lot of grief and everything else. So this is one type of problem. If you have this type of problem, you're not going to go solve the problem the same way you are with a loosely coupled system. The other type of organizations that go down this are embedded organizations that have embedded products. Do we have any embedded people here? I may not go into a lot of detail here. But in here you have emulators, you have simulators, you have the product. And what you're trying to do here is you're trying to find and do as much work as you possibly can as close to the simulator as you can, because there's less work associated. There's less duplicate testing, there's less duplicate defect finding, there's less fixing. And it's cheaper and more inexpensive to do all your testing on a simulator than it is on an emulator. And then the worst place and the hardest place to automate things is when you get out onto the actual product itself. If you take anything from this, it is these different type of factories have different challenges. It's not go off and do these things in these orders. It's put the engineering rigor in to understand your problem, understand your factory, make it visible to where we can start working on it. And then the first step that we have that they learned in manufacturing a long time ago is you cannot run an efficient factory if you're not building quality in. Deming took that to Japan and fundamentally changed it and transformed the industry. And they did that by really focusing in on process control. They spent time looking at it, and the way you do this in manufacturing is you manage the process. You track the process, you measure a dimension, and you track it over time, and you make sure it stays within the control limits, and that's how you build in quality for software. And this is because the process creates the product, and so the way we control the quality is we control the process. In software engineering, the process doesn't create the product. We have individuals that are writing code, that are doing creative work on an ongoing basis. And the way we improve the quality is by giving them feedback. We want to give them real-time feedback as frequently as we possibly can, and as high-quality feedback as we possibly can so they can improve. Everybody comes in every single day wanting to do the best job they could, thinking they're doing the best job they possibly could, and until they get feedback, they don't know to change or how to improve or how to react. But as I go to organizations and I look at them and they start to implement DevOps, what I see is they start to give the feedback to the developers and they want them to respond, and they don't have a stable quality signal to start with. I've watched more transformations auger in on this when people try to turn on and expect developers to respond, but there's not a stable signal. And that is one of the bigger motivators that caused me to want to write this book and put it in place. And what I've finally come up with is a more systematic approach to making sure you have a stable quality signal. It starts by going to an environment somewhere on your deployment pipeline, ideally further to the right. Take all your automated tests, and don't change the environment, don't change the deployment, just go into this test environment, run your automated test 20 times in a row. Take the data, dump it into the database, and ideally all those tests would either pass or fail. What I frequently find when I go into organizations is that's not the case. You typically have a bunch of tests that look like this. You have a defect in the system, so you have a group of tests that are always failing. You have some good tests that are stable and always passing, but more frequently you have a bunch of tests that are toggling back and forth. If you go off to try to do a DevOps transformation with flaky tests, it will auger in. You will end up with conflicts between those trying to drive in a DevOps transformation and developers that are trying to get their code in, because every time they go to debug and triage, they're putting a lot of energy, a lot of effort into debugging and figuring this out, and they can't find the problem. I have organizations argue with me that they need to keep these tests in because they're providing code coverage, and I will argue with you, no, you need to set these aside. You can maybe run them in the background, but you need to fix them before you have anybody looking at them, because you're either wasting developers' time trying to figure out what's going on, or you're teaching them to ignore tests. We're not going to get a successful transformation if we teach people to ignore tests. The next step we want to do is we need to figure out whether we really have these tests that are stable and we can run them in random order. So there's a very stepwise process. Select the environment, test them for repeatability. Now I want to run them in random order. Can I run these all my automated tests 20 times in a row in random order and get the same answer? And very frequently what I find is people have written order dependencies into their tests, and they can't do this. I also find a lot of organizations that can't even run this test, because there was one large organization I was working with a while ago that had a bunch of automated tests that they've automated and put it together, but it was a 2-week process to get the data set up to where they could run the automated test. It says 10 minutes. So as you go through that process, you need to run that. The next thing you need to do is make sure that your environment's stable. So you're going to want to run a lot of these automated tests in parallel and see if you get timeouts. I've seen a lot of organizations that go through this process, and what they find is they've got a flaky F5 in the system, or there's not enough memory or CPU, so the tests time out. Do the similar thing for testing your deployment process, and do the similar thing for testing your environment creation process and making sure that's repeatable and reliable. Once you have a stable quality signal, and this can be a 2 or 3 year journey, and it can take you through the whole automating your deployment process, automating your environments, automating your testing. Once you have that, you're ready to ask people to respond to the quality feedback signal. But in this case, we don't have to stop the line. I hear too many people talk in software as we pull the end-on cord and we stop the line. You stop the line in manufacturing because it's the process that's creating the product, and you want to stop the process before it creates any more defects. What we can uniquely do in software is we can gate the bad code. We can send the code back to the developer to get reworked by doing gated commits at the SCM or gated commits at the application, and then we can let the gate back open so that you can let the code flow back through. If you stop the line, you're stopping everybody in the organization from making progress. If you take the train wreck off the tracks and move it to the side and give it back to the developers, then everybody can still be productive and still have stuff flowing through the organization and becoming effective. That's a fundamental difference with software. The next thing that we do is we can't run all of our automated tests all at once. So gated commits are how we build quality in. How do we understand holes in our gated commits and what do we want to lose? Is we take all of our regression tests and we stick them into a product quality control chart. We want to make sure that we design our tests with good labels. We want to put a graphical view so we can very quickly analyze what's going on. When you have thousands of tests running, you can't look at all your tests every day, and you can't debug and triage them. But if you have a graphical view, you can quickly understand that I had a big defect get past my data commits here, and the way I'm going to improve this is I'm going to look at a test that caught this, and I'm going to go back to my gated commits, and I'm going to add one of those tests after I fix that defect. Now you won't see this. So there's an interaction between your product control charts and your quality gates that are how you build quality in and improve it over time so you can improve flow. I'm not going to get this because I'm a little tight on time. And the other thing that we look at as Goldratt teaches is to understand how do you manage flow through an organization. And software is somewhat unique. In manufacturing, they look for the constraint in the manufacturing process because somewhere in the manufacturing process, you're either processing a product or a batch of products, and the cycle time drives whether inventory stacks up in front of it. In software, whenever we do a build, deploy, test cycle, we can take all the lines of code changes that are sitting in front of it, and because of that, people tend to batch up large amounts of inventory and process it all at once. Because the costs are the same, the time's the same for doing that manufacturing process for one line of code change and 100,000 lines of code change from a manufacturing process. But this overlooks the fact that the biggest bottleneck after you start automating this stuff and get a stable quality signal is the triage and debug time. And the way we make that more efficient is we go to much smaller batch sizes. And we work through that process of smaller batch sizes and making that easy. A lot of people go off and run their automated tests once they hit dev complete or some other milestone like that. And if we're going to fundamentally change how our organization operates, we need to go not from just automating our tests to be more efficient at testing. We need to be able to automate our tests to be able to fundamentally transform how our organization works. And to do that, we run them on a more frequent basis. We run them closer to developers, and we get their feedback on that on a regular basis. And whoops. There we go. We talked about the idea of a gated commit, and when you have a large, tightly coupled system, you can gate at the going into the SCM, you can gate subsystems into going in, and you can gate it into production. And what we're trying to do here is we're trying to find defects as close to this side as we can, because there's fewer people to debug and triage than there are if you get in a large system like this. And by gating it, what we're starting with is we have these environments much more stable. And it doesn't have to be a lot of tests to start on our gating process, but it does have to be a stable quality signal. And if you want to know where to start, go to your manual testers and ask them, what about the environment that you got today, or do you usually get on a regular basis, makes it really inefficient, hard for you to do any testing? And talk to them about getting those automated. Never ask your manual testers to ever test again on an environment that did not pass those automated tests. And you do that and continually improve it, look at your test automation and work through that. The other thing with flow is we can't measure flow very well with software, because we can't measure story points or lines of code. Tell me how you're going to measure me and I'll tell you how I'm going to behave. But what I have realized, I started off by coaching people to go out in the organization and get a qualitative feel for how it's going. And what I realized later is that we can't necessarily get all the executives out there doing that. And I've seen the value of using good metrics to drive changes in large organizations. And what I have figured out is, while I can't measure flow, I can measure the waste that's slowing down flow. And those are types of things like, what's the delay in feedback? Once you have a map of your deployment pipeline, you can understand how long it takes to get through the system, and then you can map on top of that where you're finding your defects. And then in this example, 4 weeks after people have been writing code, we're finding 60% of the defects. You cannot expect your developers to get any better if you've got that big of a delay in the feedback and you're not getting through it. The other source of waste is anytime you're having to debug, triage, look at anything that's a test issue, an environment issue, a deployment issue, a data issue that can be automated, that's waste and inefficiency. So as you go to do infrastructure as code, as you go to do deployment automation, as you go to fix your test automation, you clean these things up. That's taking waste and inefficiencies out of your organization. You can measure it and you get a feel for it. And then you get into the trade-off of, you put all these big quality gates in place, you figured out how to do it. You need to make sure that these quality gates aren't stopping the flow in the organization. And what I see a lot of organizations do is they've had quality problems, so they put these huge gates or manual gates in the process, and what they do is they end up stacking up inventory. Part of making our manufacturing processes visible is what they do in manufacturing is they make inventory very visible, and anybody in an organization that sees inventory out there sees it as risk. And in software, we need to start making our inventory visible. So any inventory that hasn't gotten to the next stage in the deployment pipeline, let's start looking at the lines of code that are out there. Let's start making it visible to our leaders and our managers so that we know what's going on here and we have this type of information. It's a very systematic way for thinking about how do you understand the problem you're trying to solve, how do you start building in quality, and then how do you look at the metrics that enable you to manage flow and improve it over time. It takes an engineering rigor. It takes a view of looking at your specific application and your specific challenges. You can't just copy the latest agile practices in hopes it get better. And to be honest, I don't think you can just copy the latest DevOps practices in hopes your environments get better. You need to put the engineering rigor into understanding your problem, addressing it, and fixing the unique challenges that you have in your organization. I think those steps, stability and quality, are a big step that's going to force you to solve it. There's a lot more details in my latest book. And for people that are interested in wanting to learn more, the first 10 people that make it to my website and enter that code when you try to purchase a book, get a free book. Yes, a free ebook. Yeah, free ebooks out there, but you got to enter the code in the first 10, and after the first 10 are gone, it goes away. So So go to GaryGruver.com, click the ebook where it asks for you to enter the price, enter the DIOS1 code. And the first 10 in there will get a free book. And then I think you still want me to ask 2 questions, or are we running out of time? I have 1 minute and 6 seconds.
We'll just have one question.
Okay, one question. What's the first step to getting the organization aligned and engaged in starting to drive a continuous improvement process?
Make everything visible.
There you go. There we go.
That's why I love Kanban, because you make everything visible.
But that doesn't necessarily make a lot of the waste and everything here visible.
Can I even see it?
Yeah, you can, but let's finish up and get this here.
Okay, we can have one more question. We still have a little bit of time. One more question from Gary to the audience.
What's key in the first step to building in quality in your organization?
Hands up.
Raise your hands, please.
Okay.
Yeah.
Value stream mapping will understand the existing issues.
No. First step, before you start trying to build in quality, what do you need?
Metrics. Gates. I do gates first.
What? No, not visibility.
Quality gates.
No.
Rosaline. Yes, Rosaline.
No, not planning.
Stable quality symbol.
If there's one thing you needed to learn, that was it.
Amazing. Rosalind, please join us on stage.
Okay, then we can take a photograph with two stars.
Okay.
I've already got that. I don't need that. I got the book, right? That's enough.
Okay.
Why don't you give the book to him here?
Okay.
Both of us can read together. Then I get a photo with Rosaline also.
Oh,
Oh.
this book for Rosalind.
Please, can you take a photograph?
That's the official photograph.
Okay. Thank you so much. I really
Thank
love
you.
your talk.
Thank
Yeah,
you.
That is
Yeah, yeah.
something, how we make the knowledge work visible.
Pause word.
Thank you, Tanmay, and thank you, Rosalind, for joining us on stage. Let's give a big round of applause for Gary Gruver here. Everyone, come on, let's have some noise. Everyone. Yes, I need some noise from all of you guys. Okay, can I request Niladri sir to please felicitate Gary Gruver, President of Gruver Consulting, with a memento and a certificate.